Hello and welcome to 2-1. Today we're going to be talking about variables and expressions. Our goal today is that you will be able to identify what an expression is and be able to evaluate them. Now this is a great illustration about kind of what expressions do. So here we see $1 went in, $7 went out. $2 went in and $14 went out. $3 went in and $21 went out. So if P dollars goes in, now P dollars is just meaning any dollar amount. That variable. I could put a 4, I could put a 5, I could put a 6, I could put a 7, I could put 361. I could put however many dollars into there, and it's saying it's kind of saying what is the pattern. Now we see when it goes through, we are multiplying that number by 7. So if P dollars go in, then we need to multiply it by 7. That would be our expression that kind of describes the pattern. Okay, so let's try some examples here. We do have some vocabulary words to look at first. Alright, so here we have our vocabulary words. Now this does need to be written into your notes. Okay, I'm going to start requiring that those vocabulary words get into your notes, so I will be checking to make sure you're writing your vocabulary words. So, let's start out. Here we have the word variable. Now, a variable is a letter or a symbol that represents a quantity. Another word for quantity is a number. All right. So, and it's something that can change. So like I said with the last example on the first page, I could put whatever number in for that variable, and it's always going to give me the answer. So, let's look at the next one. A constant is a quantity or a number that does not change. An algebraic expression contains one or more variables and may contain operation symbols. Remember, our operation symbols are adding, subtracting, multiplying, and dividing. And lastly, if it asks you to evaluate a problem, the reason why they're asking you to evaluate is because you're only going to be evaluating expressions, and an expression doesn't have an equal sign. Okay, so here if we're going to evaluate, we're going to substitute a number for the variable. So we're going to take the variable out, put whatever number it says to try in for the variable, and then find the value by simplifying. And the reason why we're finding the value of it is because there is no equal sign to solve it. So that's why we use the language find the value by simplifying to kind of say solve it, but they can't say solve because it doesn't have an equal sign when we're talking about expressions. Okay, so let's try a couple here. Oh, yes. This is a quick illustration that shows what an algebraic expression is and what it is not. In order for it to be algebraic, it must contain variables. And in this case, our variable is y, w, z. Those are our variables. So these are not algebraic expressions. They are still expressions because they don't have an equal sign, but they are just not algebraic expressions because those variables are not there. Okay, finally, here we go. Get into a problem here. Evaluate each expression to find the missing values in the table. So that means I need to input or substitute the variable with the number they're asking me to substitute it for and find the value of that expression. So what that looks like. I have this expression here, w divided by 11. So I need to put 55 in for w. I need to solve it if w is 66. I need to solve it if w is 77. So first let's do 55. They kind of already did that one for us, but we'll do it. So 55, do you see how I just, right below the w, I wrote my 55 because I need to substitute w for 55. 55 divided by 11 equals 5. So that would be my value if w is 55. So if W is 66 divided by 11, I am going to get the answer of 6. So input into my table would be, value would be 6. And lastly, W divided by 11, for W equals 77. Oh, sorry guys, my pen is not working today. So my value is going to be 7. Okay, so now I have solved, or I shouldn't say solved, I should say I have evaluated this expression. I have found the missing values 5, 6, and 7. So I have completed the question. Let's try another one. Okay, now our expression gets a little trickier. 4 times n plus 6 squared. Now, underneath the 6 squared, I need to write 6 times 6. And I know that is 36 plus 4 times n. So each time I do this, I'm just going to use the 36. I don't need to rewrite 6 squared every time and solve it every time. So if n is 1, I'm going to do 4 times n plus 36 to get my answer. So 4 times 1, I have to do this first. And I would get 4 plus 36. So my answer would be 40, which is what they put in here. All right, so now let's try it for 2. 4 times n plus 6 squared. Now instead of our n, we're going to substitute our n for 2 because it says that we have to try it for n equals 2. So 4 times 2 plus 6 squared. Okay, so 6 squared again is 6 times 6 is 36. Then I need to bring down my 4 times 2 plus. All right, so now I'm going to do my multiplying. That'll be 8 plus 36, which is 44. So in the box, we'll write 44. And let's try it for 3. Okay, so I'll have my 4 times n plus 36. I'm just going to put 36 this time because remember 6 squared is 36. All right, so now instead of instead of an n, I'm going to put a 3 in there. Then I need to do my multiplying before my adding. So I do 12 plus 36, and that will give me 48. Okay, so that's all we have to do for this problem. But as you can see, it does require showing a bit of work. And I do expect to see work for every single number you're plugging in there and showing me how you're solving it using the order of operations and that sort of thing. So let's try another example. Oh yes, instead of, okay, so we're going to stop writing the multiplication sign. I know. We've been writing the multiplication sign since 3rd grade when we learned how to do multiplication. Well, now we're looking for ways to get rid of that because we're starting to talk about algebra and using the variable of x, which looks a lot like a multiplication sign. So when you're solving a problem and you see that x, you might say to yourself, is that an x? Is that a multiplication sign? And you're trying to move quickly. So we're just going to get rid of the multiplication sign as an x. So instead of x times 3, we could do this circle, that means multiplication. We could also do parentheses, which means multiplication, or this is the form I'd prefer to see, just writing 3x and knowing that I'm multiplying 3 by x. So these are different ways to write multiplying. Please write this into your notes so that you can have it. And instead of doing this dividing using a division sign, to save ourselves some time, we'll write it like this. 35 divided by y. Okay, looks a little bit like a fraction, and that's because really division is a fraction, or I guess I should say fractions are division. We're just dividing the top by the bottom, or I should say the numerator by the denominator. All right, so let's do our last problem here. All right, so a rectangle is 2 units wide. What is the area if the rectangle is 4, 5, 6, or 7 units long? So we can see from our table here, we've got 2 is our constant. It's always going to be 2. And our variable is 4, 5, 6, 7, and 8. So our length is going to be our variable. So given this nice little table, we really don't have to do a whole lot of work. All I'm doing is multiplying all of these. But if this is not the case, that it's a nice little table, you just have to multiply. You will need to show your work. So 5 times 2, I know that's 10. 6 times 2, I know that's 12. And 7 times 2 is 14. So, like I said, if it doesn't have a nice little table like this, please make sure you show your work. But if it does, you can show your work this way, by just putting the multiplying sign in and saying, well, I'm just going to multiply these two numbers together. So anyways, that's all that I have for you today. Remember, all we're doing is we're taking an expression, an algebraic expression, which means it has variables, and we're taking a number and plugging it into the variable to simplify or evaluate the expression. Okay, so we'll see you tomorrow. Thank you for watching.